Lesson 8-4, compound interest. What is compound interest? Compound interest is just the interest that is calculated based on the initial amount invested and on the accumulated interest from the previous period. So the difference between compound and simple interest, you're adding the same interest each time based on the principal amount. Compound interest is you're taking the interest on whatever the current balance is in there. So your current balance keeps improving or keeps increasing. So you would have the interest based on the principal plus the interest that was already accumulated. Because the amount earned or owed increases at a constant percent rate of change, compound interest can be modeled by an exponential function. So compound interest grows at a quicker rate than it would with simple interest. So the formula for compound interest would be A equals P times 1 plus the rate divided by N, the N representing the number of times it's being compounded, raised to the NT power. Just note that the T in time is the time in years. So let's take a look at an example. Mitchell deposited $400 into an account that pays 3.79% annual interest compounded weekly. After how many years will the balance of the account be $500? So I'm going to use the formula A equals P times 1 plus the rate divided by N raised to the NT power. We need to find out how many years will the balance of the account be $500. So we're trying to find T. So the A is going to be 500. Principal amount is 400 plus 1 plus the rate as a decimal would be 0.0379 divided by how many times is it being compounded? It says weekly, and there are 52 weeks in a year. So we divide that by 52 and then raise that to the 52 e power. To solve this now, we are going to write two equations and then we're going to graph them on our graphing calculator to find out where the two lines meet. So our one equation would be y equals 500. So each side of the equal sign is one equation, and the other one would be y equals 400 times, and I'm going to simplify in parentheses what I have there. So this would be 1 plus 0.0379 divided by 52, which will give us a longer decimal, but I'm going to keep this because we don't want to estimate until the very end. So I'm going to put this whole thing down, raised to the 52t power. Those are our two equations, and then we're going to graph them. So grab our calculator, go to the y equals, clear what I have in here. And the first one's going to be y equals 500. That's where we want to be. And then the other one would be 400 times the parentheses 1 plus 0.0379 divided by 52 and parentheses. I'm going to raise it to, and here I'm going to put parentheses 52. I know it says t, but x still works, same formula. Now that we have it in here, we're only going to use quadrant 1. So I'm going to change my Windows settings to 0 for the minimum. The maximum, let's just choose, I'm going to choose 100. I'm just making an estimated guess. I'm going to count by tens. The y minimum is going to be 0. The maximum, we need to get at least 500. So I'm going to go 100 more than that. So I'm going to hit 600. Then we're going to count those by, we'll count those by 50s. And then let's graph that. So there's your 500. And then here's the other one, which we do see. I'm going to change the Windows settings once more. I'm going to change the x maximum. Let's do 20. And then we're going to count by ones. Then hit graph. Okay, there we go. And we just want to find out where they intersect each other. So if I hit second, trace, number 5, intersect, hit enter 1, hit enter 2, hit enter a third time, and it tells us 5.889. So that would be x is the number of, or x is really our t. The t is the number of years. It will get us to 500. So 5.88 weeks, or t is not weeks, so t would be our time in years. So it gives us 5.88 years. So again, here on the calculator, you can see putting in scales here. X scale is 0 to 10. And then here we're going from 0 to 600. Scale is by 50s. Here we're going by 10, by ones. You can change those up depending on what you want. I just estimated what I would have and then based off of that one. Next example, Lucy opens a savings account with $300 and pays 2.45% interest compounded quarterly. We bring the equation to represent the balance of the savings account after 2 years. After how many years will the balance of the account be $400? Round to the nearest tenth of a year. So again, we're using A equals P times 1 plus the rate divided by N raised to the NT power. Our account balance needs to be 400. The initial amount is 300 plus 1 plus the rate as a decimal is 0.0245. And it says compounded quarterly, which means 4 times a year, raised to the 4 times the t. We don't know. We're trying to find the t number of years it would be. So again, we're going to write two equations. This is one equation, and then here's our other equation. We're going to use our graphing calculator again to solve. So we go to our y equals. This one is 400. And then down here, this would be 300. 1 plus, we're going to go 0.0245. We're going to divide that by 4. Then that's going to be raised to the 4t power, or 4x power. Then if we change our Windows settings, I could keep it the same. I'm going to change the maximum. I always go 100 more than what I would need it to be. So I'm going to go 500 since the most we need is 400. I'll keep the one at 20. Now if we hit graph, there's our 400. And then here's the other equation. See that it crosses here. Second trace, number 5, intersect, hit enter 3 times. And it tells us 11.778 years where you'll get to $400. So if I run it to the nearest tenth, that would be 11.8. Next example 2, Maria invests $5,500 into a college savings account that pays 3.25% compounded quarterly. How much money will there be in the account after 5 years? So again, I use A equals P times 1 plus the rate divided by N raised to the NT power. We're trying to find the account balance when the initial amount is 5,500 times 1 plus the rate as a decimal is 0.0325 divided by quarterly means 4 times, and it'd be 4t. Now we use our calculator here. So I'm just going to type in 5,500 parentheses 1 plus 0.325 divided by 4, end parentheses raised to the 4x power in parentheses, and hit enter. You can see our amounts. We'll do it to the nearest cent, which will make this 218,120 and 63 cents. But there was one mistake I forgot. we're told that it's 5 years, so I'm going to put 5 in for t. If I go back to my calculator and second enter, we put everything in there, but instead of 4x, I'm going to put 20 because 4 times 5 is 20. Then hit enter. That would give us 26,235. $26,205. $235 and 24 cents. That would be our solution. Next, two brothers, Amari and Jermaine, each receive $1,000 for graduation. Amari invests his money in an account that pays 2.25% compounded daily. That's key word there. Jermaine invests money in an account that pays 2.25% compounded annually. So this is one time a year. This is 365 days a year. Brother will have more money at the end of 10 years. So if I grab my calculator here, hit second enter, we're going to enter the numbers in. So the initial amount is 1,000. And the interest rate is 2.25, so 0.0 be 0.0225. Divide that by 365. And then we're going to raise that to parentheses 365 times 10 end parentheses. That gives us 1252.31. 1252.31. That one is for Amari and Jermaine. Going to use the same formula. Wait seconds, enter. Instead of 365 times, it's just one time a year. So I'm going to just delete this part. And then we're going to raise that to 10th power. That gives us 1249.20. So who will have more money at the end of 10 years? That would be Amari. And to the nearest cent, how much more money? So if I take 1252.31 minus 1249.20, we end up with $3.11 more. Earl opens a certificate deposit or a CD with $1,500 that pays 2.75% compounded daily. How much money will be in the account after 1 year? So I have A equals 1,500 times 1 plus 0.0275 divided by compounded daily is 365 raised to the 365 times 1 on our calculator. Add the numbers here, so that's 1,500 and be 0.0275. Divide that by 365. And then we're going to raise it to the 365 power. And that gives us $1,541. So it's to the nearest, I believe, nearest cents. So 1,541 and 82 cents. So 1541 and 82 cents would be the final answer. Now there's one problem I want to go back to. One here. I had put the wrong numbers into our equation on the calculator. So if we go back to this one, this would be 5,500 times parentheses 1 plus the 0.0325 divided by 4. And we're going to raise that to the 20th power. And it gives us $6,466.22. So this is wrong. So $6,466.22. So I just put the numbers wrong into the calculator. Everything else was right on that one, but I just wanted to verify that we did do that one correctly. So that is our lesson on compound interest.